And welcome back, 11th of June, higher plus 5 a day. And let's just go straight to the first one. Right, we have, okay. Keyword here is the word draw. So the word draw doesn't mean sketch. It means accurately reflect what this equation is doing. So I'm going to note that my scale is between -4 and 6. And I'm just going to plot those points. Now do bear in mind that your calculator actually has a table function as well, or should do, depending on which calculator you have. So I'm actually going to use that table function just so I'm not just putting in lots of x values. And that's going to give me, well, my x value I'm going to use are going to be -3, -2, -1, 0, 1, 2, 3, 4, 4 and 5. Sorry, a bit of squeezing at the end there, isn't it? And so therefore that's my x input. Now from the table function, my calculator, I can see the output is going to be 10, 3, I'm just reading this off my calculator, -2, -5, -6, -5, -2, 3 and 10. Now a bit of a squish at the end, which isn't ideal, but you can still read the numbers, that's okay. Now notably, what I notice here is I've got a clear turning point, and then I've got symmetry either side. That gives me a lot of confidence I've done the right thing, although I've used a calculator, so you hope I would do. Also, if you now to complete the square, half of -2 is -1, -1 negative is 1, and you can see this is indeed my turning point. So all these things make me feel a little bit better about the idea I've probably done the right thing. So now I need to just plot these points carefully. So let's plot these points. So -3 goes against 10, so -3 goes against 10, -2 against 3. And that's the last of the points I need to plot. Now again, before I put pen to paper, notice I've got a nice smooth parabolic curve. I feel I've done the right thing. Now because it's a draw question, you need to make sure you're joining up the lines carefully. So what I need, again, is something that is not too jagged at the bottom. So I need to show, and it only says between, actually, you know what, it doesn't say between any values at all, does it? So I'm going to keep it going to the end, and notably again, I'm going to get a nice smooth curve at the bottom, not some jagged point that is incorrect and will lose you a mark. So far so good. First part of the question done. Again, in your exam, well, I say use a ruler. Obviously you don't use a ruler, but as accurate as you can, make it neat. This is going to be marked by using a piece of tracing paper effectively. So you need to do a good job here. Right, next step. So it's one of these questions that I know a lot of people don't like. So I'm going to start with x squared minus 4x plus 1 equals 0. Now what you'll notice is if I add 2x to both sides, which gives me x minus 2x equals 2x, and then if I take away 6 from both sides, which gives me -5 minus 6, well then I end up with the thing I've already got plotted and a thing that's left over. And where this thing equals this thing must be where this thing here equals 0. In other words, I've rearranged an equation. So let's plot, and I'm going to change colour. So let's plot the other thing. So 2x minus 6, well, it goes through -6. It's going to be very close to the curve, isn't it? And it's going to be a straight line, so I don't need many points here. So put in 1, so 2 times 1 is 2, minus 6 is -4. 2 times 2 is 4, minus 6 is -2. You can see where this is going. I'm going to get a nice curve that happens to go through all the diagonals of these squares quite nicely. Now, remember what I said. Where these curves meet, in other words, the x values of where these curves meet, is the x values of where this function here has solutions. So let's find these out. Well, again, had I had a bigger piece of paper and done this more accurately, I'd get a more accurate response. But at least from my graph that I've drawn, I get minus, what's the scale here? It's 0.2, isn't it? So I get plus 0.2 and 3.6. Again, in the exam, you get a much bigger piece of paper. You're going to be more accurate, but that's close enough, and you'll get a little bit of margin in your answer. Either way, first question done. Next question. F of x equals this thing here. Find f minus 1 of 350. A couple of ways of doing this one. So the way that I would, well, actually, it doesn't matter. So I would note that the way, what does f of x do? Well, it multiplies by 3, then it divides by 5, and then it adds 1. So therefore, if I'm ending with 350, or in other words, starting with 350, I want to get back to the x, what do I do? What number gets me back to where I started? Well, take away 1 gives me 349. Multiply by 5, well, that's not a nice number, but anyway, calculator out, 349 times 5 is 1745. And then divide by 3, so in other words, I'm doing the opposite of these arrows, and that gives me, well, again, on the calculator, there's 1745 over 3, or I can say that's 581.6 recurring. So 581.6 581.6 recurring. So make my answer nice and clear, which is 581.6 recurring. Question done. Next question. And indeed, actually, there's a lot here, isn't there? So final question today. ACD is a triangle. Okay, so we've got a big triangle. B is the point on AC. Okay, work out the area of the triangle ABD. So ABD is a triangle that's here. Give your answer correct to 3 sig fig. So obviously it's not going to be some nice numbers because of the way it's expressed it. So thinking aloud before I do anything. In order to work out the area of this triangle, I'm going to need an angle and I'm going to need a side. Actually, no, if I use a sine rule, then if I have this angle here and this side here, and I have angle here and this side here, which I'll call Y, and then if I'd need this angle here as well in order to work out that angle, then I think that gets me there, doesn't it? Now again, I'm thinking aloud. So I've got an opposite. No, I'm still going to have to use a cosine rule. Right, there's quite a lot to this question. So let's work out this bit by bit. So let's call this theta. In fact, we'll call it theta 1, theta 2, and theta 3. So you can see I haven't actually written anything down yet. All I've done is map out what I'm going to do. So I'm not just working out things for the sake of it. Let's start by working out x, because that will give me the length. So x, using the cosine rule, is going to be 6.7 squared plus 8 squared minus 2 times 6.7 times 8 times cos of the angle in between, which is 75. Calculator out. And that gives me 9.008029, etc. So I'm going to call that 9.008. So 4 sig fig, that seems quite a lot of accuracy that I'm going to use. Okay, so that has got me to x. Now I'm going to use a sine rule, and the sine rule tells you that sine theta 1 over the opposite side, which is 8, is equal to sine of 75 that I do know, divided by x that I've just worked out, which is 9.008, which tells me that theta 1 is equal to sine minus 1. It's a good question, this, because none of it's difficult individually, but it's just carefully building up the parts. So 9.008, calculator out. And that gives me 59.0747. So again, a few decimal places here means it is more accurate. So 59.0747. You should really use at least a couple more significant figures than you're going to need in the end. So that feels okay. So that's theta 1. Then theta 2 is quite easy because theta 2 is just 180 minus that. So 180 minus theta 1. It's in my calculator already. So 180 minus answer is 120.9253. So 120.9253. Okay, and now let's remember what I'm trying to do. I'm trying to work out the area of the triangle, and of course I can also work out theta 3. So theta 3 is going to be 180 minus theta 2 minus 18. Again, theta 2 is in my calculator, so it's going to be 180 minus answer minus 18, and that tells me that's 41.0747. So 41.0747. Okay, I feel we've now got somewhere. Now using the sine rule, so y over theta 2, remember I want to find out y, so y over theta 2 is y over sine 120.9253 is equal to x, which I also know is 9.008, divided by sine of 41.0747. All that in my calculator gives me 11.7609. Now at this stage, that last decimal place is going to be a little bit dodgy, but it's okay for what I need to do because it helps me with my final answer, which I'm not going to round to 6 sig fig anyway. Right, we've got there. We've got x, we've got y, we've got the angle in between, so we can finally answer the question. The question being, what's the area of a triangle ABD? And that is going to be, well, it's going to be a half times x, which I now know is 9.008, times by y, which I've worked out to be 11.67609. Good question, this. Times by sine of the angle in between, which is 18. All of that together gives me 16.3689, etc. And I'm going to call that 16.4. And does it give me a length in units? Doesn't give me the units, does it? It does say centimeters on the diagram. So 16.4 centimeters squared. Wow, good question at the end. And again, as I've said in a few of these videos, not an unreasonable question. A lot of working out to be done. This will be nearer the end of the paper, so it'll be worth quite a few marks. But equally, nothing I did there was too hard. And that's it. Today done. Do let me know how it went for you. Do like, subscribe, and I'll see you for tomorrow. Thanks all.